right? And if the collision would have been the three-dimensional case, then it would be more complicated. But to simplify our life, we are assuming that the collision is two-dimensional, right? Okay,
Yes, sir.
so yeah, so two-dimensional collision. And before I do that, let me again ask this question: resolution of vector. This I have asked so many times, right? But let me ask this again. So if you have, let's say, r vector, and this is theta, so what would be this component?
R cos theta,
R cos theta, good, and this one,
R sin theta.
R
good.
sin theta.
Yes. So keeping this in mind, right? Let us keep this in our mind, and okay. So we have this object which is moving. Let's say its mass is m1, and this is moving with u1 velocity, right? And then we have this stationary object whose mass is m2, and this object so collide with this one, but the collision is not head on. So if the collision is not head on, which means that the collision is two dimensional. So this object, right, it will move in this direction. So this is our m1 moving with now velocity v1, final velocity v1. And then this m2 object, this is moving with velocity, right, v2. And let's say this is the horizontal direction, and because this is in a plane, so we'll have a vertical part also, right? And this angle is theta 1, this angle is theta 2. So we have so many unknowns. In this case, we have so many unknowns, right, guys? We have, what are the unknowns? We have v1, we have theta 1, we have theta 2, we have these many unknowns, right?
Yes, sir.
Okay, so this velocity is v1, and this velocity is right. This velocity is u1 vector, right? So u1 vector I wrote in the previous class. This is simply u1 I hat, and v1 was vx I hat plus vy j hat, right? Whatever the x component and whatever the y component. So this was v1, right, guys?
Yes, sir.
And v2 was vx v. So I should write v1x v1y, and this is v2x I hat plus v2y, and direction is what for v2 case? Direction is
Minus J.
minus j, right? So minus j. So this was v2x I hat minus v2y j hat. So this was our velocity of the second part. Now you guys tell me that what is the v1x? This is v1. Magnitude is v1. So what is v1x? Horizontal component.
Direction.
Direction. Yeah, so I'm asking that. Just remember the vector function, right? Whenever we have any doubt, so this is v1, and this is the horizontal component, v1x. So what would be this?
Oh, like that. V cos theta.
Yeah, so now this is v1, right? So v1 cos theta. Right, everyone, clear?
Yes, sir.
Yes.
Yes, sir.
So this is V1 cos theta. And what is V1y?
V1 sin theta.
V1 sine. Right? Absolutely right. Good. So this we have. Okay. And similarly, what is V2x? Oh, theta is theta 1, right? So this is theta 1. Yes. So V2x would be how much? In,
Sir,
yes. Yes.
V2 cos theta.
Yes. Absolutely right. And the angle is theta. So V2 cos theta. Right. And what would be V2y? This is theta 2y. This is so this one and this is V2 cos theta 2. And what is this y component?
V2 sin theta 2.
Right. So V2 sine theta. So these are the information that we have in two dimension. So you see that in the earlier case, so for the earlier case, so only in one dimension, this was in same dimension, right? All the velocities were in the same dimension, only in one dimension, right? So this was u1 and this was v1 and this was v2. So all had x direction. That is why we didn't write the y portion because y portion was right. But in these, but so for the case of two dimension, yeah, for the case of two dimension, this v1 velocity is going in xy direction. So v1 has x component, v1 has y component. And x component is v1 cos theta 1, y component is v1 sin theta. Similarly, we have v2, which is also going because this is not in same direction as u1, right? So this is in two dimensions. So we have two components, x component and y component, right? Which means that,
Yes, sir.
yeah, so which means that x component is v2 cos theta 2 and y component is v2 sin theta 2. So clear up to this point or any confusion, guys?
Clear,
Yes,
sir.
sir.
Okay, so now we will assume that for simplification, we will assume that this collision is elastic. So we have elastic, right? Now for the elastic collision, what is the first criteria? Yes, guys, what is the first criteria? Momentum, or let me write as linear momentum is conserved. And now because we are in 2D, so that is why we will write the vector portion because momentum is a vector quantity or a scalar quantity. What is vector? What is
Vector.
momentum? Vector quantity, right? So we will write in the vector form. So v initial that would be equal to v final in the vector form. Clear? Is this part clear, everyone?
Yes, sir.
So P1 initial plus P2 initial, this would be equal to P1 final plus P2 final. Here is this clear?
Yes, sir.
Clear, sir.
So this would be MQ1 vector plus this is how much? So this is M1 1 and this is M2 U2 vector and this is M1 V1 vector plus M2 V2 vector. Clear?
Yes, sir.
Okay. So then what is VU2?
Sir, can we take?
What is U2
No,
guys?
nothing is common.
Nothing. Yeah. So not I'm not talking about the common part. What is U2? How much is U2? Do we have
Zero?
a yeah? So that is right. This is zero. And how much is U1? How much is U1 vector?
U1 I cap?
Absolutely right. So this is U1 I cap. Right, everyone. Similarly, we have this M1 and V1 is how much? So this is V1X I cap plus V1Y J cap. Correct.
Yes,
Similarly,
sir.
we have M2 and this is V2X I cap minus V2Y J cap. Any doubt in this, guys?
No, sir.
No, sir.
So now we have to compare, right? This is I, this is IJ. So we have to compare left and right because this is an equality sign. So left hand side should be equal to the right hand side. So let us write this as V1I. And this is how much? M1 V1X I hat plus M1 and V1Y J hat plus M2 V2X I hat minus M2 V2Y J hat. So we have to write I in one part, J and J in one part. So let us write that. So this would be M1 U1I and M1 V1X I plus M2 V2XI. So this is one part. And then we have this M1 V1YJ minus M2 V2YJ. Okay. So then this would be how much? M1 U1 I hat equal to M1 V1X plus M2 V2X I hat plus M1 V1Y minus M2 V2Y and J. So now we can compare the left and right hand side of the equation. Is this part clear?
Yes, sir.
So if I compare the I with I, so what I will get?
1.
Comparing both the sides. I is 1.
Sir, I into I is 1, right?
Yeah, I dot I is 1. I'm not taking the dot product. Am I taking the dot product here? I'm comparing both the sides. Right? So what is the coefficient of I in here? And what is in here? That should be equal, right? If two vectors are equal, let's say A and B are equal. If two vectors are equal, which means that their direction and their magnitudes are equal, right? So let's say if this is AXI plus AYJ and this is BXI plus BYJ. So this AX should be equal to BX and this AY should be equal to BY. Then this vector would be equal, right? This is what I'm
Yes, sir.
talking about. So
Yes, sir.
now do you guys understand this part? So these two
Yes, sir.
vectors, right? This is, let's say, some A vector, and let's say this one, right? Whose X component is this one, and Y component is this one. So this is B vector. These are equal. So X component should be equal, which means M1 U1. This would be equal to M1 V1X plus M2 V2X. This is equal, right? And do we have any J component in here?
No, sir.
So I can write this as, I can write this as 0 into J, right?
Yes, sir.
So this would be 0 equal to M1 V1Y minus M2 V2Y. So is this part clear, everyone?
Sir, can you explain again?
Yeah. So you see that in the left hand side, what is the coefficient of J?
0.
0. And in the right hand side, what is the coefficient of J?
0.
Eh, Well, why this? This is this one,
Oh,
right?
yes, sir.
This is the coefficient of J. So this one I have written, right? Here.
Okay. Yes, sir. Clear.
Now I know all these values. So I know what is V1x and V2x. I know this much, right? So V1x was, this was V1 cos theta 1, right? And V1y was V1 sin theta 1. Similarly, V2x, this was V2 cos theta 2, and V2y was V2 sin theta 2. So this we have discussed earlier. So let us plug in values. Let's say this is so simplifying this. So this would be M1 U1 and M1 V1 cos theta 1 plus M2 V2 cos theta 2. So this is the first equation. Okay. And from this one we have 0 equal to M1 V1 sin theta 1 minus this is M2 V2 sin theta. Okay, so we have M1 V1 sin theta 1. This is equal to M2 V2 sin theta 2. So this is the second equation that we have. Any doubt up to this point, guys?
No,
No,
sir.
Okay, so please note down up to this part, and then, so one thing we have used, right? For the elastic collision, we have used the conservation of momentum. So what is the other thing that we have to use? Yes. What is the
Sorry,
other?
sir.
So for the elastic collision, we have used that the linear momentum is conserved. What is the other thing that we have to use?
Kinetic energy is conserved.
Yes, absolutely. So the other thing that we will do is that kinetic energy is conserved. But you guys note up to this point, and yeah, please note it down.
Yes.
That is why we are in the fifth chapter and we are still getting vectors, right? So that is why vector was very important.
Yes, sir.
And when we will do this rotational portion also, so again we will come across this vector part. Yeah, whenever you guys want me to scroll down, please this part, part one is going in this direction, right? This is one, one. And this is one sine theta. Right. Whenever you guys have any confusion, just break the diagram in part by parts, and then it would be easy to understand.
Okay, sir.
So can you scroll?
Term was what? Mass into velocity, right? Where this mass is a scalar quantity, this velocity is a vector.
So can you scroll? Done, sir.
Done. Okay, so
Done. Done, sir.
Then everyone, Akif, Rishita,
Yes,
Amna,
sir.
okay. So now we have these two equations, right? And as Akif was saying that we have to use the second thing also. So kinetic energy is also considered. Kinetic energy is considered. So we have these, right? This one is at rest. This particle is moving with U1, and then it strike this one, and then they go different sides. So then they go in different. So this is going with V1, and this is going with right. And this one is M2, this one is M. So what would be the and kinetic energy conservation? So kinetic energy initial, this would be equal to final kinetic. So you guys tell me that what kind of, so what kind of physical quantity is kinetic energy? Is this a vector or a scalar?
Vector.
Vector, kinetic energy is a vector quantity. Okay, so Akib is saying that this is a vector quantity. Yes, Rishita, Elham, and Amna. What about you guys? What do you guys think?
Sir, it's a scalar quantity.
So Elham is saying that it is a quantity. Rishita and Amna, what about you guys?
Scalar.
It's a
Okay.
scalar quantity, sir.
So
Because it does not have a direction.
yeah,
Yeah.
kinetic energy, yes, absolutely right. So kinetic energy doesn't have its direction, right? And from the formula, we can also see that from the work energy theorem, we can also find out that from the work energy theorem, right? What does it say? So work is change in kinetic energy, right? So work is what kind of quantity? Work is a scalar quantity, right?
Yes, sir.
So that is why this kinetic energy is also a scalar. And we can also see it from here. Kinetic energy is half mv square, right? Velocity is a vector, but v square, which is v dot v. So dot product, this is a dot product, which is a scalar product, right? So this is a scalar, this is a scalar, scalar into scalar is a scalar. So the this is a scalar quantity. So we don't have to worry about those directions, right? Momentum was a vector quantity. That is why we wrote it in terms of I, J, and all those things, right, everyone?
Yes, sir.
So in this case, kinetic energy would be how much? This would be half. I'm writing it directly. Mu1 square plus half M2 U2 square. This is half M1 V1 square and half M2 V2 square. Right, so this is 0. This is cancelled and I have this one. M1 U1 square. This is equal to half M1 V1 square plus half M2 V2 square. Okay, so this one is the equation. This one is the third relation. So what do I have? I have known, what are the known things, known terms or known quantities. What are those? So one is M1, the other one is M2, and then we have this one. Right? What are the unknown terms? What are the unknown terms? Unknown terms are V1, V2, and do we have anything else?
K1.
No, sir.
One and zero.
Yes, yes. What are you saying, everyone?
U1 and U2.
U1 and U2, we know already. What was the speed with which it was moving, right? U2 is 0. So we know that this was at rest. So U1 we know, and M2 we know, M1 we know, U2 we know that is 0, right? So V1 we don't know, V2 we don't know, and what do we have any other things that we don't know? Yes, guys. Just check the first and second equation and tell me, do we have any other unknown quantity?
Y-
Yes, guys.
Sir, cos theta, sin theta.
Yeah, so you are nearly correct. So we have theta 1 and theta 2, right? So these are the unknown terms that we have. And whenever in a question they ask you to solve this problem, so we cannot solve this problem, right? Because we have how many equations? We have three equations, right? One, two, three. So we have this one, then the second one, and then this third one. And we have four unknowns, right? We have four unknowns and we have three equations to solve. So we cannot fully solve this equation. That is why in your question, so in the question, one of the value would be given. So one of theta 1 is will be given, right? So if theta 1 is given, now how many unknowns do you have? Three unknowns, and you have three equations. Then you can solve this one, right? Remember the linear equation in two variables. So you have 3x plus 4y equal to 7. So can you solve this equation?
Yes, sir.
You can solve this equation. So how can you
Oh,
solve it?
sir.
Can you get x and y from this equation? You need pair of linear equation, right? 2x plus 3y equal to 5. When I give you the other pair, you need two equation, right?
Oh,
To
yes, sir.
solve for x and y. So x and y, you have two unknowns, right? So whatever the number of unknowns are, that much number of equation you need to find out the values of unknowns, right? So in this part, we will have, when we have these four unknowns and three equations, then we cannot solve. But in the question, they will give one value of theta 1. So then we would have three unknowns, right? Then you can solve the equation. So is this clear, everyone?
Yes, sir.
Yes, sir.
Yeah. So these are the three important equations that we have to remember. So please note down this kinetic energy one, and then we will do one question. So one more property is there which we have to talk about, but I will talk about after doing one question. Okay, so please note down this part and then we will do the question. what now. Yeah, you guys please note it down, and whenever you want me to scroll down, basically that.
Done, sir. Done, sir.
Could everyone note it?
Yes, sir.
Okay, so let us do one derivation again, and then we'll do the question. So, what do we know? We know that we have an object moving with u1 velocity, right? This has mass m1, and this was the stationary object m2. Then this one strike this one, and then m1 goes in this direction with v1 velocity, right? And m2 goes in this direction with v2 velocity. And this angle is theta 1, this angle is theta, right? So the question is that if m1 equal to m2, then you have to show that those particles will go in the perpendicular direction, right? Which means that what would be theta 1 plus theta 2? So we have to show that if m1 equals to m2, then so let's say this is theta 1, and this is v1, and we have to draw the perpendicular. So this is perpendicular, and this is theta 1, this is theta 2, right? This is m, this is m, this is m, and this is m. So if m1 equals to m2 equals to m, which means that masses are equal in elastic collision, right? Remember, this is in elastic collision. So in elastic collision, we have to prove that if m1 equals to m2, then what is this condition? What is we have to prove, right?
M1 V1 is perpendicular to M2 V2.
So angle, we are talking about the angle, right? So
Yes, sir.
theta 1 plus theta 2. These are the angles. So this would be how much? Yes,
90 degree.
90 degree, right? So this we have to. Okay, is this part clear, everyone? Is this part clear?
Yes, sir.
So these, in the previous cases, the masses were different. But if the masses are same, right, then we have to show that this theta 1 plus theta 2 is 90. Okay, so how can we show that? So let us use first equation. The first equation is, right, first equation is conservation of moment. So from the conservation of momentum, what do we have? P1 or let's say P initial vector, this is equal to P final vector. This is P1 initial plus P2 plus P2 initial plus equal to P1 final plus P2 final, right? And now the masses are equal. So this is MU1, right? And this is MV1 plus MV2. Is this correct, everyone? Is this correct?
Yes, sir.
Yes, sir.
Okay, so if I take this is let me write it as run can. Now what I want is that I want to calculate the dot product. So let's say this is A, which is B plus C. Correct, everyone? Is this part clear?
Sir, please can you explain again? Your voice was lagging.
My voice is lagging. So am I audible now, everyone? Am I audible? Yeah. So I have this U1 vector, and then you have this 1, 2, 3 vectors, right? So I have this A vector, which is B plus. Clear?
Yes, sir. Yes, sir.
So
Clear.
now what I want is that I want to calculate the dot product with A. Is this part clear?
Yes, sir.
So this would be B plus C dot B plus C. Clear? Is this part clear?
Yes, sir.
So what would be A dot A? If I take the dot product with itself, how much is that?
A dot A.
Yes,
It should be 1.
A dot A is 1. Okay, so this part I did
2U1.
is 1.
Yeah, because A's value is 2 U1, right?
Okay, so you guys have forgotten the dot product. Let's say I have A and I have B. So what is A dot B? Definition of dot product, scalar product. What is that?
Sir, A dot B,
Yes, A dot
it
B.
will be
Yes, all of you
A
guys,
magnitude into B magnitude into cos 90 or cos theta.
absolutely right. Good. So this is A dot B, right? So now if I'm calculating A dot A, then this would be how much? A magnitude, and cos of what is the angle between A and A? I have this A vector, right? And I have this A vector again. So what is the angle between A and A?
0.
0. So this would be A square. Now do you
Yes,
guys
sir.
remember? So A dot A would be A square, right? So I should do this calculation in here, but just for the analogy, I'm doing this, right? So this would be how much? B dot B plus C and C dot B plus C. So this would be B dot B plus B dot C plus C dot B plus C dot C. Guys, this is clear.
Yes, sir.
So what would be B dot B?
B square.
B square. And B dot C is equal to C dot B. So I should write B dot C. and this is v square. So any doubt up to this point, guys? Any doubt?
No, sir.
Okay, so I have, right, so I have, let me write, so taking the dot product with u1, right? So I'm writing it directly, right? And you guys have understood that why I'm writing. So u1 square is v1 square plus v2 square plus 2 v1 dot v2. Clear, everyone?
Yes, sir.
Yes, sir.
Okay, so let us keep this part in here. So let's say this is one equation, right? And remembering the diagram. So this is the diagram, right? V1 is this vector, V2 is this vector. What is the angle? Angle between V1 and V2, what is the angle? Angle
Sorry, sir.
between,
B1 and B2.
yeah, angle between V1 and V2. How much is that?
90 degree.
No, no, so that we have to prove. But in this case, from the figure, what is the angle?
Yeah, that's it. 90 degree, right? It's looking.
No, so whether it is looking or not, we have to show mathematically, right? There should have some proof. Mathematics or physics is all about logic. So the looks can be deceiving sometime, right, Akif? Yeah,
Yes, sir.
but from the figure, what we can say? What is the angle between V1 and V2?
Sir, from figure only I'm telling it is looking 90 degree.
Yeah, so I have written this is theta 1, this is theta 2. So now can you guys tell me what is the angle between V1 and
Theta 1 plus theta 2, 90 degree.
no, so theta 1, this part is correct, right? This is the angle between V1 and V2. And this is what we have to show, right, Akif? So this is
Yes,
what
sir.
we have,
That's why.
yeah, so that is why this we have to show mathematically, right? Yeah, so but we know from this figure that theta 1 plus theta 2 is angle between V1 and V2, correct?
Yes, sir.
So if I take V1 dot V2, this would be how much?
So theta 1 dot theta 2, like that.
No, so this is angle between V1 and V2, right? Theta
Yes,
1
sir.
plus theta 2 is angle between V1 and V2. What is the dot product? That this is just you have said, right? A dot B. What is that?
Sir,
A,
V1, V2 cos theta.
yeah, cos theta. But what is this angle between V1 and V2? What is the angle?
Theta 1 plus theta 2.
Yeah. So this would be the dot product of V1 and V2. Is this part clear, everyone?
Yes, sir.
Okay, so now let us use this
So
relation.
theta 1 plus theta 2 is 90, right?
So that we have to prove, right? So that we have to prove. That theta
Yes,
1
sir.
plus theta e is 90. That we have to prove, right? Whenever the masses are equal, so this is the proof that we have. That whenever the colliding masses are equal, then after collision they will go in perpendicular direction. So that we have to prove. We have to prove that theta 1 plus theta 2 is 90, right? Yeah, we don't know what is the theta 1 plus theta 2, but we have to prove that that is 90. Okay. Yeah, so now let us write that result in here. So this is V1 square plus V2 square plus 2 V1 V2 cos of theta 1 plus theta 2. So is this part clear?
Yes, sir.
Now we have this one. So what is the other thing that we are missing? What is the other thing that we know?
U2 is 0.
The u2 we have already taken 0, right? So what this is, remember this is an elastic collision. What is the other thing that, yes, conservation of momentum we have done. So
That conserves the moment, right? That's it.
yeah, conservation of momentum we have used, guys. What is the other thing that we have not?
Oh, kinetic
Yes,
energy
yes.
is
So
conserved.
yeah. So this part, conservation of kinetic, right? So from this, what would be the kinetic energy? Half m u1 square plus half m u2 square. This is equal to half m v1 square plus half m v2 square. Correct, everyone?
Yes, sir.
Yes,
So
sir.
this part is 0 and we have half m u1 square and we have half m v1 square plus half m v2 square. So let us take half m common. This is v1 square plus v2 square and this is half m u1 square. So this part is cancelled and what is the relation that we have? u1 square equal to v1 square plus v2 square. Right? Let's say this is the third equation. So now, can we use this third equation in the second equation? Yes, guys.
Yes.
So now let us put the value of whatever u1 square or v1 square plus v2 square. Right? So putting the value of v1 square plus v2 square in equation second. So we have u1 square. This is equal to u1 square plus 2v1 v2 cos of theta 1 plus theta 2. Correct, right?
Yes, sir.
So this part is cancelled and we have 2v1 v2 cos of theta 1 plus theta 2. This is 0. Right? So is the velocity of first and second particle 0?
Yes, sir.
V1 is 0.
No, V2 is 0. Sorry, U2.
Yeah, so this V1 is not 0, V2 is not 0, 2 cannot be 0, right? So we take this quantity in the right hand side and we will have what? Cos theta 1 plus theta 2. This is 0. So now you guys tell me that cos of something is 0. So at what angle cos is 0?
90.
90, right? So this is, I can write 0 as cos 90. So cos cancels and I have theta 1 plus theta 2 is 9. So this we needed to, right? And yeah, so is this clear? So the from the image, from the figure, it was looking like it is going in the 90-degree, right? So let's say I draw this diagram, right? I draw, let's say this is M. Okay, this is M and this is M. And it strikes and this one goes in this way and this one goes in this way. So if I draw this diagram, right? So what can you tell Akif now? This is not
Nothing.
looking like 90-degree, right?
Yes, sir.
But the masses are same. So from the theorem or whatever we have done, now we can say that if from the diagram, right? We know that we have made this diagram, right? But from the this proof or from this derivation, we know that theta 1 plus theta 2 would be 90, right? Whenever the masses are equal and they are colliding in elastic collision, then this these angle would sum up to 90, right? So this is the
Yes, sir.
so whenever we have equal masses colliding in a two dimension, then the angle between them after collision is 90. So this is the important result that we have. Okay. So please note it down. And if you guys have any doubt, please ask.
No, sir.
Yeah. So please note it down. This we have wanted to, so we have to prove this. This is the condition that we have. And if you guys have any questions, please ask. Yes, Akib, what are you currently watching?
Sir, now nothing.
Oh,
Today they
yeah.
gave me timetable of my midterm exams.
Oh, oh, midterm exam. So when is that happening?
Sir, this 11th.
Oh, this 11th. This 11th. So today is 8th. That is why I was telling you to just revise
Sir,
yeah,
second exam is physics.
second exam. Yeah, prepare well, right? Just start.
Yes, sir.
So just put all your efforts from now. Leave everything else and just focus on, concentrate on only the preparation, right?
Yes, sir.
Otherwise,
So
yeah,
can you scroll?
this part is guys all right. So then what disconnected?
Can you scroll?
The next question is exactly like this, and we'll do that question and then this chapter. In the next class, I'll start rotational, and rotational will take at least 3 to 4 classes. That is not that important, so I will focus mainly on gravitational part.
So done.
Then, oh, this part already. What you guys said. Yes, noted, guys.
Yes, sir.
So whenever everyone is completed, just
Yes, sir. Done.
what is
Sir, done, sir.
okay. So now let us do some question to understand. Like,
Sir, ये click print out.
yeah. So whenever you have a PDF, you just insert by printing it out, right? In one. Otherwise, it is. So when you upload the file, then this would not appear, right? PDF form, when you upload the file, then it will not appear.
Yes, sir.
Okay, so what was the question that I was talking? Yeah, so did you guys try this question? This one? This is a very important question, and yeah, so I will discuss this question at some point. But what should we discuss? Yeah, so this question. Yeah, this one. Consider the collision depicted in 5.1 to be between two billiard balls with equal masses. The first ball is the cue ball, while the second ball is called the target. So the billiard player wants to sink the target ball in a corner pocket, which is at an angle of theta 2, which is 37. Assume that the collision is elastic and the friction and rotational motion are not important. So obtain theta 1. right? So 5.10 is 5. So this is 5.10, and it is given that, right? So now you guys know the result, right? So now you guys already know the result. So first we will do with the, so there are two balls, right? This is so cue ball is white, right? So this is a cue ball, and let's say this is the target ball, and this is the pocket, right? So this is a billiard table, and you have this cue ball which is at this angle which is theta, right? And this is the cue ball, and this is the target ball, and this is the theta, right? This is not going in the pocket because that would be a foul. So let's say this is theta, right? So the question is that what is this value of theta? Okay. So without doing all these lengthy calculations, you guys know that this is equal mass of this one. So these masses are equal. And so what are the given things? It is given that
M is equal.
M1 is equal to M2. This is given. It is also given that collision is elastic.
Sir, can we write theta 1 plus theta 2 is 90?
Absolutely right. Good. So collision is elastic. So without doing all those calculations, we know that theta 1 plus theta 2, as Akib said, that is 90 degrees, right? So then theta 2 value is given. So where is that? Yeah. So theta 2 is given, and we have to calculate theta 1. So theta 2 is 37 degree, right? So theta 1 would be how much? This is 37 and this is 90. So theta 1 would be 90 minus 37. So this would be how much? 3 and so you guys see that without doing all those lengthy calculation, we got this. Just for this information that masses are equal, right?
Yes, sir.
Yes, sir.
Okay, so you guys note down this problem, and what we'll do in the exam, let's say if that question is given in 5 marks, so then we have to do all those calculations. We cannot write this one, right, everyone? So
Yes, sir.
Yes, sir.
yeah, so please note down this part, and then we will do the full calculation. We have 5 minutes. Let's see that. Yes, everyone. So did you guys understand this part?
Yes, sir.
Yes, sir.
This was the billiard board. I think it were the pockets. And this was the stick, right? And here it was Arctic. So Arctic was taking shot. So which one of you guys have played the billiard?
I played.
Sir, I played.
You have played in reality or in mobile?
No, sir, in
Both.
reality.
I have,
Sir, but who uses physics in using playing billiards, sir?
yeah, who uses this physics? So physics is everywhere, right? In a day-to-day
No, sir.
life.
Who uses this type of calculation in billiards?
Yeah, so you see that when you want to, when you want this ball in this pocket, right? So at which point you should strike this ball. So this you have to remember, and this you can calculate
Yes, sir.
using the
So
physics,
this
right?
mental perception is used for.
Yeah, so you have to strike this ball in this part, right?
Sir, isn't Bismillah enough?
Yeah, yes.
Isn't Bismillah and you throwing the ball is enough?
So Allah helps you. Allah has provided you with the brain, right? So that is why. So He has given us the brains to use, right? And we have got these ideas using our brain. So that has some use, right? So if you say Bismillah and then you throw these, so then you strike the ball, then it will not go into the pocket, right? So you
Sir,
have
I did this many times. It happened.
okay. So that is some random thing, right? Because randomly those are striking, and one of the cue balls, right? Let's say if there are many cue balls, right? Let's say eight. There are eight balls on the board, and you are striking randomly, right, with many of force. So then, due to this collision, right, random collision. So let's say there are this many balls, right, eight balls, and then you strike this one with certain, let's say, velocity, with high momentum. Then this will strike this one, and this will strike this one, and this will strike this one. So all of these ball will strike each other, and some of the balls, right? Some of the balls will have some velocity with which it will go in this direction, or let's say it will go in this direction, or it will go in this direction. So in that sense, also you use physics, right? The idea of collision, right? Okay,
Yes, sir.
because let's say you are striking, so this is the arrangement, right? So this is how the balls are arranged, right?
Yes, sir.
And then you strike those balls in here. So this will strike in this direction, right? This will strike this ball in this direction. So these ball will go. So that is why these ball go in this direction. Let's say if you strike this ball in here, right? So it may happen that it will not go in the pocket. But when you strike with maximum force at this ball, then there is some chance that the balls will go in the pocket, right? So then you use the idea of collision, right?
Yes, sir.
Yeah, Allah is there. Of course, if Allah wills, then anything can happen, right? But He has also given us the brain, right? So we have to apply those tiny brains of ours, right? Okay. Yeah, because let's say all the living things and non-living things, we are special because we have what?
We have brain.
We have brain. They also have brain, but they don't have a free will, and they can't go against Allah's will, right? But Allah has given, we are special, and Allah has given us free will. That is why we do so many mistakes. And yeah, okay, yeah. What we doing? Oh, we were about to do this problem. So I will give this problem to you guys to solve, and we have to follow the same steps, right? So
Yes, sir.
we have to follow the same steps, and the idea would be the same, right? So as you can see that these are the, how do we get this relation, that you already know, right? So
Sir, it is
follow,
answer.
yeah, this is the answer, right? So you guys can check the answer, or you guys try this question without using this idea, right? Without using this idea, please try this question, right? And all these steps that we have done it already, right? So
Okay,
you,
sir.
yeah, you check the notes and follow those notes and just put the value of theta 2 in that equation. Then you'll get the result. Okay.
Yes, sir.
Okay. So we will stop it here, and in the next class we will start. Right. In the next class we'll start this linear or system of particles. Right.
Okay, sir.
Okay, and all the best, Takib. Start preparing, right? Start preparing, and how many days? Oh, so your exam is starting on 11th, right?
Yes, sir.
You have 2 days, not 2 days, but 3 days. So all the best, and yeah, do well, do well.
Thank
Okay.
you, sir.
Yes, Allah Hafiz, everyone. Bye.
Thank you, sir.